Hello and Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5, which is the title is the recyclable material classification by using convolutional neural network (CNN). So, uh, this is the our group member. This is Awina Miriul. I am Muhammad Adi, young kid, and also TK Weekly. So, Assalamualaikum again to my lecturer, Dr. Ain. So, first is the introduction is we have five points that the internet is flooded with image, videos leading to the development of search application that analyze visual content. And the major breakout have been achieved in tasks like pictures, labeling, object detecting, and sense classification. So third is the convolutional neural network have played a significant role in this advancement. For a point is CNN excel at locating object in image and video and categorizing scenes accurately. So last point is this breakout have improved the performance of search application, resulting in more accurate and relevant search results. So uh, for my last part of my presentation is methodology, which is to construct and simulate CNN model based on specific number by using Google Collaborator software. There are consists of several parts, which is first is from the flowchart is we start. So mount Google Drive to Google Colab. So we import on OS module and check and set the current working directory. So next is import important libraries that will aid in the design. Next is we create train data and validation data directory. So next, return and print the random input data image from the list. Next, we set the data image to size 150 multiplied by 150, and this and the three colors are channel S3. Next, we design the architecture of convolution, which is consists of the convolutional layer, like convolutional layer, pooling layer, flatten layer, and dense layer, and so on for create the model. And next, we rescan and pre-process the train data and validation data. Next, we start the training process. After that, the screen we display the filters of map in different layers. Next, we plot the outcome result for M1, and then if the M1 model is good training and validation accuracy, so it's go to next step, which is pick the pictures of that bottle, PET bottle, and aluminum can, which is captured in three conditions into model 1, M1, and analyze the outcome. And then it's will end the simulation. So I think that's all uh, for the presentation for me. Thank you.
Good evening, my name is Evina. So as for the software that we have used is called the Google collaborator which we have used to gain the result that we have achieved for this assignment. So basically, the software is used for it allows us to write coding and execute it in Python, which is online, and it is also helps us in terms of importing an image data set to train an image classifier and evaluate the model through the coding. Next is the result that was gained for our test 1 model, which is the graph of training and validation accuracy and the graph of training and validation loss. As you can see here, the design model's training accuracy and validation accuracy are 100% and 99.52% respectively, as shown in the first graph. So the difference between the training accuracy and validation accuracy is 0.48%, indicating that the training model is a good fit, and it shows that it doesn't have any underfitting or even overfitting. So additionally, there is also no gap between the training and validation accuracy graph after 8 approach, indicating that the proposed model has a high learning rate for image classification. The graph of the training loss and validation loss displayed in the second figure shows that the gap between the training loss and the validation loss is almost zero. Next, after the training and validation process, the optimal model M1 is safe. So the next step is to perform the recyclable material classification on the prepared testing image that we are required to gather, which is an aluminium can and PET bottles. So 3 testing image with 2 objects at different distance are used in the classification process. So by using the prediction function, we can obtain the result which is displayed in the tree of the image that as you can see here. So based on the display result, the optimal model M1 is able to predict and detect 1 can and 1 PET bottle in each testing image despite the position and the distance of the item. So as you can see here, the first image show that the PET bottle is side by side with the aluminium can, and the second bottle is the PET bottle is in front of the aluminium can within 15 cm distance, and the third image shows that the aluminium can is in front of the PET bottle within 15 cm distance. So and each of the results shows that it is able to identify both of the aluminium cans and bottle despite the position and the distance. So as you can see here that this is the coding, the Python coding for task 1 in our GoogleColab. So as you can see here that we have already import our GoogleColab data which we have uploaded in our Google Drive, and then once we import all of the required files, and then we are able to build the CNN model by using the by adding each of the layers. So as you can see here, this is the result that we have gained for the layer and all of the max pooling, and the total parameter is 917,921, which is also equivalent to our calculation that we have done. And the next step is to see the data of our approach, which we have set to 10, and each of it has gone to 47 times of training. So at the side here you can see its loss, accuracy, its validation loss and validation accuracy for each of the approach. And this is also our the coding where we are able to plot both graph, which is the training and validation accuracy, and the training and validation loss, which I have already explained in the previous slide of its data that we have gained. And this is where we are going to test the image classification to see whether that our trainer are able to identify each of the images with the same material, which is the aluminium can and the PET bottle. So we are able to see whether it is able to identify despite the distance. So just as I have shown before, it is exactly the same outcome. Yeah, so this is basically the demonstration for the how we achieve the result.
Hello and Assalamu alaikum warahmatullahi wabarakatuh to my lecturer and all my group members. So first of all, I would like to introduce myself. I'm Mohammed TK Mcleod, my matric number AE20097. So I would like to present my part, which is the methodology of task 2 that we are using for our assignment. Actually, we have to choose two train model. We are deciding to choose VDD train model and DenseNet train model. So firstly, I will start with the VDD train model. So as you see the pair flow chart in the slide, start, then pre-train type VDD16, and then construct CNN model by using the collect data. We have load the data from the Google Drive, and then import the relevant file. After that, construct pre-training model. Lastly, feed pre-training model to structure architecture, which is the construct CNN model. We feed it to the structure architecture, and then pre-process the input data and setting the step per epo validation step to start the training process. Then to get the result of the CNN model VDD16, we plot the outcome of the CNN model. Then we end the process, and then my friend, in the next part we will showing this process and steps. For the next model that we use it for the methodology of task 2, DenseNet train model, almost the same of the first model, which is the VDD, but the difference which is in the construct or CNN model. So first start pre-train type DenseNet, and then construct CNN model by using the collect data, and then loading data from the Google Drive. Here we have a little bit different than the first model, which is the VDD. Here we have in the DenseNet train 2D convolution layer, after that max pooling, and then flatten and dense. Then we go to the next process, which is pre-process the input data. After that, setting the step per push and validation step to start the training process. And to get the result for the DenseNet train model, we plot the outcome of the CNN model to get the result. Then we end the process, and also this process my friend will show you in the demonstration video. Thank you and have a good day.
So this is my program for the VGG16. We are using the GoogleColab. We import the program inside here, and this program all same with the first, for the first task is the same. We just change the import to the VGG16. That's all, and then we didn't. And then we just direct to the flatten part. We didn't use the layer. We will freeze the layer and then we direct go to the flatten, and then we run the program. We will get the result, which is this one. I will explain more in the for the result in task 2. And then we go to the DanceNet. This is a program for the DanceNet 1-to-1. We just change over here. Just now is import VGG16. Now we import the DanceNet 1-to-1. And then let's see for the result down here. Yeah, this is the result. So I will explain more in the result in task 2 in the slide later. That's all from me. Thank you. Good morning, doctor. My name is Yongkit Somkiat. Matrix number DE 2026. So for my part today, I want to tell for the result in task 2, which is we are using for the CNL model for the VGG16, and one more we are using the CNL model DanceNet, which is 1-to-1. So as you can see, result in task 2 for training and accuracy, which is a bit lower than the DanceNet. It is like percentage is around 70%, and for the losses, which training losses, which is 60% something. And then for the DanceNet, it is quite good for the training and accuracy, which is almost 100%, almost perfect. And then for the losses is very good, which is near to the 0. That's all from me. Thank you.
As a conclusion, we are able to successfully build 3 different CNN models and to determine which one with the higher accuracy, and so that we are also able to acknowledge the importance of the CNN models in terms of the image classification and the need for modification to achieve the optimal performance. Hence, we are also able to discuss the significant vision system problem and how it has been explored using the method and concept of vision system designing. So it shows that we are able to acknowledge that the DanceNet 1-to-1 model is the most effective CNN model due to its high training and validation accuracy, and it has a low training and validation loss. Also, we are able to acknowledge that it is challenging to establish the superior CNN model since the architecture can be varied, depends on our application. Hence, there are a few recommendations that we are able to suggest where we suggest in increasing the number of training and validation data to improve the validation accuracy of the model. Additionally, data augmentation can be also employed to increase the diversity of the data, which includes techniques such as flipping image and zooming in and on to the image. So to improve the model ability to learn the data sets, we suggest by adding more layer to the model, which allow it to detect and recognize the minute differences among the dataset fed into the model. We also suggest increasing the number of epochs so that the learning rate for the model can be increased by its training with more approach with the different intervals to improve the accuracy of the model. So that's all from us from group 5. Thank you.